Hello everyone! In this lesson, we will continue to learn the time domain analysis module of continuous systems. 7th, zero-state response of systems solved by convolution integral. After introducing convolution into the previous content, according to the linear time invariant property of the system, using convolution integral of system input signal or excitation signal and system input response to solve zero-state response YZS of system. Let's take a look at such example. System as shown in the figure below. Calculate the zero-state response of the system when the excitation is unit step signal. It offers us the time domain diagram of the system. First of all, we need to get the mathematical equation describing the system from the block diagram, and use convolution integral of excitation and impulse response to solve the zero-state response of the system. We see that there are two integrators in the block diagram. Generally, we set the output of the rightmost integrators as xt. The output of these two integrators are the second derivative of x and the first derivative of x. Write the input-output relations of two adders at the left and right ends respectively. And after eliminating the intermediate variable xt, we get the following description: mathematical equations of the system. Let's see. This is a second-order differential equation with constant coefficients. Select new variables y1. Let us satisfy such an equation. That is, the right end of the equation contains only one ft. The impulse response of such a system is h1t. So we have a relationship like this, because excitation is a unit impulse signal at this time. So how about when the unit impulse signal is greater than or equal to 0 minus? Is equal to 0. So at this time, the equation can be written as follows. It's a homogeneous equation. H1t, the form of its solution, is a form of homogeneous solution of the equation. Let's look at the coefficient C1, C2. We need to use 0 minus to find the value of 0 plus. And then find out the undetermined coefficients C1 and C2. This part in the previous chapters, I've already said that we need to use balanced matching method. We can get 0 minus value to 0 plus value. In the end, we get a value of 0 plus. It finds out the undetermined coefficient C1 is equal to 1, and C2 is equal to minus 1. With the expression H1t, according to the properties of LUTI system, we can get the expression of HT of response. Finally, we use convolution to get the zero-state response of the system. Pay attention here. To find the convolution of unit step signal and impulse response of system, we can use the differential and integral properties of convolution. It's going to work together. The zero-state response of the system should be equal to the convolution of the first derivative of the unit step signal and the first integral of the system impulse response. The first derivative of the step signal is exactly equal to the unit impulse signal. This result should be the convolution of the integral of the unit impulse signal and the impulse response of the system. We know that the convolution of any signal and impulse signal is still its own. Thus, the final result of the whole subject is the integral of the impulse response of the system. We will be here for this lesson. Thanks.